Hey guys, this video is about 4.2 multiplying matrices. Now it's not the same as scalar multiplication like you did last section. Scalar multiplication, remember, is if you took a number and you multiply that by a matrix. This is going to take a left matrix and a right matrix and you're going to multiply them left by right. Okay, so before we do that, let's look at these examples. And right now what I want you to do is to write these down, and I want you to pause the video and I want you to write down the dimensions of this matrix, of all three of them. Go. Okay, so hopefully you've done that and you didn't cheat. This is going to be a 3 by 2 matrix, 3 rows, 2 columns. This is going to be a 2 by 3 matrix, 2 rows, 1, 2, and 3 columns, 1, 2, 3. And this one here is a 3 by 2 matrix also. So it's important we remember the dimensions because in matrix multiplication, it is super important that you understand the dimensions of a matrix. Not all matrices can be multiplied by each other. And some matrices can be multiplied by each other left to right, but can't be multiplied by each other right to left. It's important you understand that the commutative property is not going to happen in matrix multiplication. Okay, it's not necessarily applicable. So what I want you to understand is when you multiply matrices, so let's look at matrix W and matrix X, it's only possible if the number of columns in the left matrix equals the number of rows in the right matrix. Now by saying right and left, I mean this. I mean W times X this is my left matrix and this is my right matrix. Now I could obviously switch these and call it XW, which now X is my left matrix and W is my right matrix. So let's think about this. So if I took W and multiplied it it's a 3 by 2 matrix, and I multiply it by a 2 by 3 matrix, which would be matrix X. Well, if you notice, the columns in W, there are 2 of them, and the amount of rows in X, there are also 2 of them. If this is true here, if these equal one another, then the new matrix that you get by multiplying is going to be the number of rows of the left-hand column or left matrix times the number of columns of the right matrix. So this actual, when I do WX, its matrix that we do when we multiply is going to be a 3 by 3 matrix. Okay, so let's think about X times W now. Well, X times W is going to be a 2 by 3 matrix, and it's going to be multiplied by a 3 by 2 matrix. So can we multiply these? Well, these equal each other. These rows and these columns, these columns and these rows equal each other. So we get a 3 by 3, or 3 equals 3, so that's good. So then 2 by 2 is going to be the matrix that we get when we multiply. It kind of looks like a cowboy hat, which I don't wear any of those, but that's cool. So a 2 by 2 matrix, and that's what the new matrix will be. Okay, so let's do an example. Let's actually do this matrix here, X times W. Let me show you how we do this. Let me write down X. We get it's 4, 7, negative 2, 5, 1, negative 1, and W is going to be 3, negative 2, 1, 0, 2, negative 1. Now, I'll be honest with you, the first time you see this, it's going to be a little tricky, so I want you to pay close attention. Feel free to rewind this video often to make sure you know exactly what you're doing. Now, the answer to this, we already said, is going to be, well, this matrix here is X, and this one here is W, so this was a 2 by 3, and this is a 3 by 2. So the answer to this matrix is going to be a 2 by 2 matrix. And I'm going to put it kind of big, just so you have some space, because there's going to be some math that you got to do in here. So the answer to this one is going to be a 2 by 2 matrix. So these 3's equal one another. That's good. The answer will be a 2 by 2 matrix. Now the trick that you have to do in order to do this is you need to multiply the row from the left matrix, so the first row, you're going to multiply this one, by the column of the other matrix, the first column. Okay? So what you're going to do is you're going to take each of the entries and you're going to multiply them together. So we're going to get 4 times 3. And then you're going to add them to the next entry. So 4 times 3 plus 7 times 1. So we took 4 times 3 and we're going to add that to 7 times 1. And that and as we continue, is going to go into this first entry in my multiplied matrix. So 4 times 3 plus 7 times 1. And then we have to add, we're not done yet, we have to add negative 2 times 2. So we're going to go 4 times 3 plus 7 times 1 plus negative 2 times 2. Now, for real, I don't even think of this anymore. I legitimately just do this, and my fingers do the job. They do it on their own. I've trained my hand to do that with a lot of matrix multiplication. So negative 2 times 2 is going to be the next one. And so this actually is going to become the actual entry when we do all the arithmetic out, and that will be our answer for this. So for the very first entry, we're going to get 4 times 3 is 12. 7 times 1 is 7, so that gives you 19. And then negative 2 times 2 is 4, negative 4. So 19 minus 4 is going to be 15. So this here is all for the top left entry. Row 1, column 1, row 1, column 1. Okay? Now in order to find row 1, column 2, this entry here, which will be all this math here, which I don't think is going to fit in there, so bear with me. It's going to be row 1 times column 2, and we're going to add up those all together. So let's do this. And I'm going to do this in black in this one just so you can kind of see it a little better. It's going to be 4 times negative 2 plus 7 times 0. And if you don't know what that is yet, that's not good. Plus 7 times 0. So 4 times negative 2 plus 7 times 0 plus negative 2 times negative 1. Okay, so let me show that again slowly. 4 times negative 2 plus 7 times 0 plus negative 2 times negative 1. Well, this isn't too bad. 7 times 0, you know, is 0. Negative 2 times negative 1, that's going to be positive 2, and this is going to become negative 8. So your answer is going to be negative 6 for this entry. So in the row 1, column 2, you multiplied and added row 1 and column 2 of the left and right matrices. So again, remember, this is your left matrix, and this is your right matrix. And again, we've been doing x times w. Okay. So now let's try to do these last two entries. We're going to take row 2 now and multiply it by column 1. And so that's going to go down here, and that will become this entry here. Okay. So we're going to get 5 times 3 plus, so 5 times 3 plus 1 times 1. Plus, so 5 times 3 plus 1 times 1 plus 2 times negative 1. And as you get better with these, you don't really have to write all these things down. Like, you don't need to write 1 times 1. You know what that is, don't you? So 5 times 3, that's going to become 15 plus 1, that's 16, and then minus 2, that's going to become 14. So this entry here is 14. Okay. And let's do this next one. This last one here is going to be the second column, second row. So row 2, column 2. So we're going to take row 2 times column 2. So we're going to get 5 times negative 2 plus 1 times 0 plus negative 1 times negative 1. 5 times negative 2 plus 1 times 0 plus negative 1 times negative 1. So let's do that now. 5 times negative 2 plus 1 times 0 plus negative 1 times negative 1. 1 times 0 is 0. This will become negative 10, and this will become positive 1. So we're going to get negative 9. So this here, this matrix, is equal to x times w in that specific order. Okay, it's important to understand it's x times w, not w times x. Because if you look back up here, we remember that w times x is actually going to become a 3 by 3 matrix. Okay? So what I want you to think about right now is do these examples. So take these examples here. What I want you to do is write these down, pause the video, and I want you to tell whether each product is defined, and if so, give its dimensions. Okay? So pause the video and do that. Okay, so hopefully you've paused the video and you've done this. Let's check this out. This is a 3 by 2 matrix. This is a 2 by 3 matrix, and this is also a 3 by 2 matrix. So A times B, that's going to be a 3 by 2 times a 2 by 3. Well, these are equal to one another, so that's good. So yes, this product is possible. And what would be the dimensions? Well, a 3 by 3. So A times B is going to give me a 3 by 3 matrix. Okay, now let's try B times A. B is a 2 by 3 matrix. A is a 3 by 2 matrix. Well, again, these are equal to one another, and that's good. So my answer is going to become B times A will be a 2 by 2 matrix. So again, I want you to notice that commutative property of multiplication is not going to work necessarily in matrices, because A times B produces a 3 by 3 matrix, but B times A produces a 2 by 2 matrix. So you got to make sure you understand that. Now A times C, A is a 3 by 2, C is a 3 by 2, and oh, check this out here. 2 does not equal 3. This is not good, so this is not possible. You cannot multiply the matrices in that order, A times C. Now let's see if we can do C times A. Well, C is a 3 by 2, and A is a 3 by 2. And again, check that out. These do not equal one another, so this is not possible. Okay? So you cannot multiply those matrices. All right. We're almost done. What I want you to do is go back to those matrices. You should have written those down or rewind them. And I want you to multiply matrix A times B because we showed that those were possible. And I want you to multiply B times A. Okay? Multiply A times B and then multiply B times A. So pause the video and try to do those and let's see what we got. So A times B is going to be, it was 4, negative 2, negative 3, 10, 2, 6. And B was 4, negative 1, negative 5, 3, 2, 8. We know that we can matrix multiply. A times B is going to become a 3 by 3 matrix. So it's important you understand that this is going to be a big matrix. So give yourself lots of space. So for the first entry, 4 times 4 plus negative 2 times 3. So 4 times 4 plus negative 2 times 3. 4 times 4 plus negative 2 times 3, that's going to be this entry here. Okay? And the next one will be negative 2 times negative 1. Excuse me, hold on. 4 times 4 plus negative 2 times 3, sorry. 4 times negative 1 plus negative 2 times 2. So it's going to be plus 4 times negative 1. Not plus. 4 times negative 1 plus negative 2 times 2. Shoot. 4 times negative 1 plus negative 2 times 2. Mr. Blair's losing his mind. 4 times 4 plus negative 2 times 3. 4 times negative 1 plus negative 2 times 2. See how quickly you can easily mess up? Don't do that. And the next entry is going to be 4 times negative 5 plus negative 2 times 8. Okay. 4 times 4 is going to become 16. Minus 6 is going to become 10. And this here is going to be 4 times negative 1 is negative 4. And this becomes also negative 4, so this becomes negative 8. And this becomes negative 20 and minus 16, so this will become negative 36. Okay, let's continue. Now we're into row 2. Row 2. So row 2, and this is column 1. So row 2, column 1 is going to become negative 3 times 4 plus, so negative 3 times 4 plus 10 times 3. Negative 3 times 4 plus 10 times 3. And then, so we can do that one right now. Negative 12 plus 30, and that's going to become negative 12 plus 30. And I'm drawing a blank. Negative 12 plus 30, that's going to become 18. And so then this next one will become negative 3 times negative 1 plus 10 times 2. So negative 3 times negative 1 plus 10 times 2. Negative 3 times negative 1 plus 10 times 2. So this will become positive 6 and 20, so this becomes 26. The next one will become negative 3 times negative 5, and then 10 times 8. So negative 3 times negative 5 plus 10 times 8. Plus 10 times 8. Plus 10 times 8. So negative 3 times negative 5, that's going to become positive 15. 10 times 8 is 80, so it becomes 95. So you continue going on with that. The video is about to end. I only got a few seconds left. But this is the idea. Continue doing these sort of things. Next section, you're going to talk about the determinants of matrices, and that's going to be it for all of Chapter 4. Hope you guys do well. Say hi to my fish.